Hey guys, this is Miss C here, and today we are going to talk about arithmetic sequences. And so these are your notes for 2.10, and here we go. So first off, before we get into arithmetic sequences, we're just going to define what a sequence is. So a sequence is a function whose domain is a set of consecutive whole numbers, which means that the domain for every sequence is 1, 2, 3, 4, 5, 6, 7, going on forever. Consecutive whole numbers. So we don't consider fractions or negative numbers or zero part of the domain or the inputs of a sequence. Okay, and so then the range or the outputs or the y values would be the terms of the sequence, meaning what you're actually looking at when you're looking at an arithmetic sequence. And so it can be specified by an equation or a rule, which is really what we're going to focus on today, is how to write these sequences using equations and rules. And so the first type of sequence we're going to look at in Unit 2 is called an arithmetic sequence. And so an arithmetic sequence is a sequence of terms that have a common difference between them. And the fancy way of saying something is being added or subtracted from term to term. And we will look at some examples like that in a second. And so the first thing we're going to look at is the explicit formula for an arithmetic sequence. And when you think of something being explicit, it tells you exactly how to write something. And that's what this formula does. And so what we see here, this before and after, right? So we have a sub n equals a sub 1. Sub just is what you say when you have a subscript. And so a small letter n below the a equals a sub 1 plus d times n minus 1. So we first need to talk about what all of these terms are. So a sub n, what that is, it's the term you're looking for. Okay. A sub 1 would be the first term in the sequence. D would be the common difference. And n, the n is important because we see n both in our a sub n and in our formula here we see an a sub n and this n minus 1. So what is n? And that is the order of the term. And what I mean by that, I know that might sound kind of strange, is if you're looking for the fifth term, that would mean that n is equal to 5. If you're looking for the ninth term, n is 9. So when you have questions that are asking you, what is the 10th term, you're plugging in 10 for n. So now that we have everything defined and we know what all of these different variables and parameters mean, let's look at this before and after. So the important thing with the explicit formula is that we always simplify. We see that in this before we have to distribute this d, and so when you guys are working on problems and having to write arithmetic sequences in an explicit formula, what you're going to end up writing is a sub n equals dn plus a sub 0. And this will make a lot more sense as we go on, but d is still the same. D is your common difference. A sub 0 is your 0th term, but like we said in the notes above that, our domain for a sequence, we start with 1. And so this 0th term, I think you will start seeing what that 0th term actually means and the connection even to the rest of Unit 2 as we work through an example down here. So first thing we need to do is determine if this sequence is an arithmetic sequence. And so how we do that is a little trick, if you will, would be right minus left. So you take your term on the right and you subtract your term on the left. So 5 minus 2 is 3. Okay, so now we need to take the next term. So we do 8 minus 5. So we go 8 minus 5, that's 3. Okay, so far the important thing is that the common difference has to be the same between all of the terms in the sequence. So then I'm going to do 11 minus 8, and that is also 3. So that tells me that my common difference is 3. And so yes, this is an arithmetic sequence. So this first question just asked us to determine if it was an arithmetic sequence. Now it wants us to find the explicit equation. And so if we go back to our notes above here, I want you guys to get into the habit of always writing the explicit formula so that you can commit it to memory, because this is something very helpful to know. So a sub n equals a sub 1 plus d times n minus 1, right? And so what we need to find in order to write this explicit equation is a sub 1 and d, right? Well, a sub 1 is just the first term, and we can clearly see our first term here in the sequence is 2. And then our common difference, we just found that in the previous part of this problem, and d was 3, because each number is growing, you're adding 3 each time. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, and so on. So now that we have a sub 1 and d, we can fill in the rest of this equation. And so we have a sub n equals 2 plus 3 times n minus 1. And remember, we have to simplify this, and so we need to distribute this 3 to everything inside the parentheses, and so then we are left with a sub n equals 2 plus 3n minus 3. Combine your like terms, and you are left with 3n minus 1. So when you are writing your explicit equation and simplifying it, your parentheses need to be gone and your like terms need to be combined, and you will be left with an equation looking something like this. And so this is really, if you look again above, earlier in the notes, this after that we wrote, this a sub n equals dn plus a sub 0. We can see that our 3 shows up here in front of our n, and so when your explicit equation is completely simplified, you see it here. You see your common difference being what's multiplying by your n. And then this term at the end, this negative 1, well, I want you guys to think about that for a second. What could this a sub 0 mean? And so look at this next part of the notes here, and how else could we represent this sequence? So you probably are wondering, why the heck are we talking about arithmetic sequences when we've been talking about lines and we've been talking about systems of equations, right? And so I want you guys to look at this. So we have this a sub n equals 3n minus 1. Now this looks pretty similar to y equals 3x minus 1, right? Or just like something we learned last week with function notation, y is the same thing as f of x, so we can say f of x equals 3x minus 1. So the cool thing with arithmetic sequences is really they are just, they look a lot like linear functions. However, they're slightly different, because if we were to graph this, well, let's first create a table here of our values. So we have our x, our inputs, and our outputs, right? And so our inputs in our list here were 2, 5, 8, this was the first term, second term, third term, and fourth term. And then what we got with those values was 2, 5, 8, and 11, right? 1, 2, 3, 4. Okay? And so if we were to then graph that, okay, and we're only dealing with positive x values here, right? Because positive whole numbers 1, 2, 3, 4. And then if we were to make our y-axis something like this, we would start at 1, 2, and plot these points. 2, 5, something like that. If my pencil would write. 3, somewhere around there. And then 4 might be off the chart a little bit. And so the important thing with arithmetic sequences is that since they are consecutive whole numbers, I'm not going to connect these dots, because connecting the dots, just like we do with a line, shows me that every possible value between 1 and 2, 2 and 3, 3 and 4 work for that line, right? Like for y equals 3x plus 1, I can choose a value of x being 1/2 and get an answer. But with sequences, we don't deal with fractions or negative numbers, and so you would graph a sequence just by using dots for your whole numbers here. So your outputs could be fractions, but your inputs, your x's, must be whole numbers here. And so that's why arithmetic sequences fit into Unit 2 here, because they really are a line. And so if you think about if we look at our line, what this -1 would be here, and I said earlier how that's your 0th term, well, think about it. That would be your y-intercept, right? And so that's when x is equal to 0 and your line crosses your y-axis. That's where that -1 comes from, and that's the connection between sequences and lines in this situation. So I'm trying to show you guys the relationship there. And so now we're going to look at this next problem. So the important tool for you guys to learn here is how to determine if a sequence is arithmetic is to always remember we're doing right minus left, and we're seeing if there's a common difference between them. So if we subtract 1/2 minus 1/4, you would end up with 1/4. Okay, let's now try the next two terms. So we have 1 minus 1/2. So I just did 1/2 minus 1/4. Now I'm doing 1 minus 1/2. Well, that's 1/2. Those are not the same values, and that means there is no common difference here. So that means no, this is not an arithmetic sequence in this problem. So then we wouldn't need to move any further in this situation. So let's go to the back page of your notes here. And so now, again, we're going to determine if the sequence is arithmetic. And so we're doing right minus left. So we're starting at 3 and subtracting 7. So 3 minus 7 is -4. Okay, that negative is important, guys. These numbers are getting smaller as we move left to right. So your common difference is going to be negative because you're subtracting something each time. -1 minus 3 is -4. Okay, it's looking good so far. And the last one, -5 minus -1, would also be -4. So yes, this is a arithmetic sequence, and the common difference is -4 in this problem. So now that we have determined that it is, we can now find an explicit equation for it. So again, I'm going to get in the habit of writing a sub n equals a sub 1 plus d times n minus 1. That's our formula here. And I'm going to plug in my a sub 1 as 7, because that's the first term in this sequence. And then remember, we found d in this last part of this question, which was -4. And so now I am plugging in those values in for my a sub 1 and my d. So a sub n equals 7 plus -4 times n minus 1. And remember, we are distributing this -4 to everything inside the parentheses, that n and that -1. So we have a sub n equals 7 minus 4n plus 4. And this leaves us, once we combine our like terms, a sub n equals -4n plus 11. Okay, and then again, you guys can see how we represent this. So as a sequence, we write this as a sub n equals -4n plus 11. And you can think of it as y equals -4x plus 11, or even as f of x is -4x plus 11, and see the relationship of a function. So this 11 here is your 0th term, or in function terminology, it's your y-intercept here. And so again, if we were to create our table of inputs and outputs, remember, we always start our sequences with our first term, second term, and then however many terms they give you in the problem. And so we have 1, 2, 3, 4, and we have 7, 3, -1, -5 as our outputs. And so again, if we were to graph this, two, three, four. So if I am starting at x equals 1, and I am starting up at 7, and then at 2, I am at 3. 3, I go down to -1. And 4, I am down at -5. And again, we don't connect our dots because it's not a function. This is a sequence. The reason I'm showing you guys this y equals and this f of x is for you guys to really be able to see this positive 11 here. This 0th term is your y-intercept. And another way to think of it is your common difference is also your slope. That's what you're changing by each time. Down 4, right 1, down 4, right 1. So yes, cool. Okay. So for this next one, pause the video. I want you guys to find the common difference and to write the explicit formula. And I will come back and we will go do this one together. All right, so we found the common difference here, and so 9 minus 3 is 6, 15 minus 9 is 6, 21 minus 15 is 6. So that means our common difference is 6. A sub 1 is 3, which we see right here. Okay, and so now I can write my explicit formula. And so a sub n equals a sub 1 plus d times n minus 1. I'm plugging everything in. A sub n equals 3 plus 6 times n minus 1. Combining my like terms. And then, or distributing and now combining my like terms, I'm left with 6n minus 3. Okay, how'd you do? Common difference explicit formula. This is what you should have gotten once you simplified. And so now this problem is asking us to find the 10th term, right? And so if you go back and remember what all of our variables mean, finding the 10th term means we are finding when n is equal to 10. And so if you want to, when you pause the video, decided to try this part of the problem as well, good for you. And so if there's two ways you can plug this value in. So we're first going to use the simplified version here, okay? And so we are trying to find a sub 10, okay? So I am plugging in 10 for my n value. So a sub 10 equals 6 times 10 minus 3. Okay, so a sub 10 equals 60 minus 3. A sub 10 equals 57. So that is your 10th term here. I would highly discourage you from, if you are looking at the sequence here and you're like, oh, I just need to add 6 every time. Well, this is the 4th term, and so I'll just keep counting up until I get to 10. That's great until I give you a problem that's asking you to find the 53rd term. And I don't think you would want to count up to the 53rd term. So knowing how to plug n into an equation is so helpful here, guys. But another way you could have done this is instead of using your simplified equation, you could have gone back to your original formula that you had. So you had a sub n equals a sub 1 plus d times n minus 1. So this is just another way you could have solved this. And so you had a sub 10 equals, and then we plugged in our a sub 1 as 3 and our d as 6. And then we plugged in our n as 10 minus 1. And so I could simplify all of that. 3 plus 6 times 9. A sub 10 equals 3 plus 54. A sub 10 is 57. You get the same thing either way. I think you guys started realizing there are several ways to get to the same answer, whether that was learning that with systems of equations or right now. But both ways of getting the answer is totally okay and totally acceptable and right. Okay, so that is the gist of writing arithmetic sequences in an explicit equation. So now we are going to talk about the recursive notation. So we just talked about explicit notation. Now we're going to talk about recursive. So the reason we talk about recursive, honestly, it's not super helpful unless you are doing coding or things with computers. They don't have a huge help in the real world, because the issue with recursive is that recursive is all about using what came before it to solve the next problem. And so if you look at this equation, we have a sub n equals a sub n minus 1 plus d. And you might think that, oh, there's a blank here, I need to fill something in. No, when you're given the recursive formula, they tell you what a sub 1 is, because that's the only way to solve this. Because let's say you were trying to find a sub 10, so if I plugged in 10 here and 10 here for n, so it would be a sub 10 equals a sub 9 plus d. It's like, well, I don't know a sub 9, so I need to find a sub 9 equals a sub 8 plus d. And then again, you have to keep working backwards. And so that's why we really use and talk about the explicit formula. But recursive is necessary because just like these problems right here, you have to be able to go between the two of them to be able to problem solve. So for example, this problem here gives you a problem in explicit form, and it wants you to write it in recursive form. And so the things that you need for recursive form are d and your a sub 1. Here, we'll use different colors here. I used yellow for a sub 1 above, so we'll do that, and then d is green. Okay, everything else stays the same. Recursive formula, again, like I said, not super helpful, to be honest with you, to just find any term that you're looking for. So the first thing we're going to do, so the first step to converting is you want to plug in 1 for n to be able to find your first term, to find a sub 1. Okay, so we're going to do that first. So a sub 1 equals 3 times 1 plus 8. A sub 1 equals 3 plus 11. A sub 1 equals 14. Okay, and then we need to find d. So step 2 is to find d. And remember, we talked about this earlier in the notes, that your d is right next to your n. So your d will also always be right there in your explicit form. And so then we have d is equal to 3. And so now that we have everything, we can write our recursive form as a sub n equals a sub n minus 1 plus 3. And then you use this little semicolon here and say a sub 1 equals 14. That's it. That's how you write something in recursive form. So this is a super important skill to be able to go between the two forms that will definitely show up not only on a test or a skills check, but the EOC loves problems like this, to be able to go between forms. And so now we're going to go from recursive to explicit. And so they tell you what d is, and they tell you what the first term is, right? And if we look in the explicit form, we need to plug in a sub 1 and plug in d. So your step here, it's really simple. You plug in a sub 1 and d into the explicit formula. Okay, and so we have a sub n equals a sub 1 is 5 here, plus, here, wait, let's go back and write it out, just in case I lost anyone here. So a sub n equals a sub 1 plus d times n minus 1. So I am plugging in and simplifying. And so my a sub 1 is 5, so I have a sub n equals 5 plus - 3 times n minus 1. Okay, and then I'm distributing that -3. And I'm going to write up here now, a sub n equals 5 minus 3n plus 3. Combine my like terms, I end up with -3n plus 8. Another important thing, guys, is that remember thinking about your 0th term. This plus 8 here will never, ever, ever match your first term. This value here will never be the same as your first term, ever. Again, think about it. Your y-intercept isn't the same as the term that comes right after it. If it's a line, then it has some sort of slope going on, right? And so that is an important thing to recognize as well. So now you're going to do these next two problems on your own. And so this first one is I'm going to give it to you in explicit form, and you're going to write it in recursive, and then opposite for the next one. So a sub n equals, let's do -2n plus 7. And then the second one here is a sub n equals a sub n minus 1 plus 5. And then a sub 1 equals -1. Okay, so pause the video, do these two on your own. All right, and so then for your recursive form for number 1, you would have a sub n equals a sub n minus 1 minus 2, and then a sub 1 would equal 5. Okay, and then for number 2 here, we would write this in in explicit form, and so you would be plugging in everything and getting a sub n equals -1 plus 5 times n minus 1, and you would end up with -1 plus 5n minus 5, and a final answer here of a sub n equals 5n minus 6. Again, these values will never be the same. But hope that was helpful, guys, going through the notes. Make sure to do the 2.10 practice and turn that in by midnight on Monday, and have a good rest of your day.